I've done video bits before, and they're mostly 5 to 10 minute segments centered on one topic. This video will be slightly different. It's going to be part of a byte, and these will be a longer string of videos that progress slightly slower, so I record all the details for my future self, say for repairs or something like that. And in this first byte project, I'm going to be working on a transceiver for 40, 20, and 15 meters, and that's going to replace that guy. And a lot of this preparation actually comes from the issue of obtaining a lot of parts. And for me, this mostly means pulling caps out of old devices. Like all these caps here, these electrolytics, are all recycled, and I just pull them out and label them. That's it. And it's, well, taking me a long time to get all these different parts. So I finally got a good set of resistors, and you can see here I've got ceramic caps of different values, and I've got my lots of different types of diodes. And keep in mind, all these are like kind of like 60 cents, and you wait a month from China to get these shipped to your mailbox. And I've got a couple of types of transistors. 2N2222s are the most common guys, and I've got a couple of RF transistors and audio transistors and things like that. And in addition to that, you also need weird things like toroids and, you know, copper wire and things like that. And this list just goes on. So you also need test gear, some of which can be quite expensive, but you can build some of that on your way. So the most basic one is your multimeter here that I've got, and these are Harbor Freight's Centec cheap multimeters, and they'll almost usually give it away for free if you buy something with their store. That's not always the case, so you kind of have to wait for the right time for that to happen. Now, to work on RF stuff, you really can't get away with not having a scope. And here, this is a tech scope that I've gotten quite recently, actually. And I've got another guy, an older guy over there. And that's really, really useful for debugging and trying to figure out what's happening. Without a scope, you're kind of lost. And I don't have money or anything like that for a spectrum analyzer or any sort of fancy power supply, so, you know, you gotta make your own power supply, and that takes some time to research and figure out how to do. And capacitance, inductance meters, well, my Arduino actually takes care of a capacitance meter. Inductance meter, well, you just measure capacitance and then stick in the scope over there to measure your inductance. And there's just a whole slew of parts that are available, and that's what makes hobby electronics kind of hard to get into. So this is probably, by the way, why a lot of people are obsessed with coding these days, because there's a very, very low entry barrier. And so now that I've got all this stuff, I think I'm finally ready to put together a transceiver. So right now I'm going to go ahead and lay out my goals. Alright, so here's what I want out of this transceiver. It's going to have to be tri-band, so that's 40, 20, and 15 meters. I want it to be CW, SSB, I don't know, I don't think it's going to be that hard to expand to SSB, but I don't actually want SSB. That's not something I like to do. In fact, I don't think I've actually tried it yet. But I want it to be SDR capable, and that means that I want to have an audio input to, say, a computer or something like that, and have it be able to process signal and display like a band scope type thing. So this is going to be just 2 mixers or something like that. Okay, so I'm going to focus really on the CW for hardware. And so this is going to be definitely a superhead. I'm not going to bug with the DC converters because they just kind of suck. This must be cost efficient. Okay, I'm not going to pay more than what, $20 in parts for this thing. Like, that's max, and I want it to work well too. So I'm gonna have to be doing a lot of designing by myself, and that also brings me to another point, and this is going to be as few these guys as possible. So I don't want any black boxes. and that means mysterious ICs or, you know, random processor chips and things like that to pop into this receiver transceiver. And that's because it just makes more sense to have radio as discrete components. And like right now these days, like these tablets and things like that, these are all like, you know, when you tear them open, they're going to be just processor chips and things like that. It's not very fun to look at. Like, you don't know what's going on. So as few of those as possible, unless, of course, it saves a whole lot of time, or it helps expand or meet any of these other objectives in a much more efficient way, in a cost-efficient way. Okay, and another thing is, other than no black boxes or few of them, I want this thing to be modular. It has to be 100% modular. So if I have one setup going, say I have a filter that I don't really want, I can switch it out for something else and just have it kind of like plug into place, and I can move on with, you know, operating transceiver. So it has to be modular. And another thing, it's kind of like a self goal. It's not really a transceiver goal, but it's a this. I want to understand at least 90% of what goes into the transceiver, because, you know, it's really easy to look up some schematics online for different pieces and bits of transceiver, but understanding them is kind of a whole entire different story. So I want to be able to understand at least 90% of what I'm doing. And lastly, this has to be, well, I want to be computer controlled. So that means that I can read the signal off of it, which was, again, like the SDR requirement here. And the other part of it is to be able to read the frequency and things like that into my computer, so I can, you know, save stuff or record stuff on the computer. So this is kind of like bringing your average radio into the modern age. I'm going to be doing a little bit of digital stuff, which means black boxes. But I'm going to see if I can avoid them at all. I'll try to do so. So this is really the goals. This is what I'm going to try to do in the next, you know, 8 to 10 videos or something like that. Yeah, and I'm going to get started by just doing a very, very quick block diagram. Okay, as all you radio fans might know, we're going to start over here with our lovely antenna. And we're going to end over here with our speaker. Okay? So in the middle here, we gotta convert the signals into sound. And we're going to do that somehow in the middle, okay? So the current plan is to go here and have a module for low pass filter. So that's what? This way, right? Low pass filter, and I'm going to go into a mixer, oscillator down here. This is probably going to be a digital oscillator, or like a frequency synthesizer thing that I have a couple of here. And, well, this has to be able to be controlled by a computer. And I don't know what the symbol for computer is, but computer or something similar. Now from this mixer, I'm going to have some sort of kind of bandpass filters. And keep in mind, this is just a RX path. I'm going to keep these receive and transmit paths almost completely separate other than the oscillator. So all these filters I'm going to do separately for both sides. So these can be kind of low-powered guys, and I'll do a high-powered series for the transmit side. And I'm going to go for 10 watts or so. Just kind of like a minimum, and you know, I could build PAs after that, but 10 watts is what I'm aiming for here. And after this filter, it's probably just going to go into another mixer with... Okay, here's going to be the interesting part. If I want to make this an SDR capable thing, I can't just do like a CW detector and have it blast out a tone or detect something on the frequency. I've got to actually take the whole entire segment of the band and put it into our audio output. So, I mean, I guess just some sort of other programmable oscillator Maybe I divide this down or something like that. I am not totally sure how this is going to work, because I only have one module of AD9850, and then also have the SI5351. These are DDS type things, and we'll see how that goes. But here, we're going to go, let's move this over, I guess. We're going to have more filters. We're going to go into audio amp, lots of it, and then we're going to go into our speaker, right? So this is kind of your basic superhet receiver diagram, right? And you know, keep in mind, as this is going to be completely modular, I can at any point say, like, break this connection here and kind of add in, you know, some sort of amplifier or something in there to boost up signals. I might do some AGC stuff over here, and I might also add in a couple extra, like, filter boards, switch relays for different bands and things like that. But this is kind of the basic plan for the receiver. Okay, now for the transmit path, it's going to be, I'm going to try to keep it very, 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 very simple. So it's just going to be an oscillator here, okay? And that's going to go into some amplifier, some more amplifiers, some more amplifier, and we keep going, and eventually it goes into our lovely antenna. That's it. Like, really, that's it. We might think of something extra to put in here later, like filtering, you know, that's going to be built in somehow. And yeah, that's very, very rough plan. I haven't thought this out too much yet. But I'm going to actually start working on the receiver first, because that is kind of your base of their radio. There's no radio if there's no receiver. Okay, so in the next video, I'm going to actually start with the putting the parts together for a receiver.